Good afternoon. First of all, many thanks to the organizers of this interesting webinar, in particular to my friend Augusto Zanella, that is always ready to face the new challenges without preconceptions and without partisan interests. I'm working with Augusto on the ALBA project. It's a project that began last year with the aim to study if and how is possible to achieve the goal of zero carbon emission on the island of Albarella. Albarella is a private tourist island of 550 hectares with 2,800 buildings, mostly second homes, so with a restaurant, swimming pool, tennis courts, with the waterproof surface is about 80 hectares. In this island, there is also an extensive wooded area that cover about 80% of the island. Annually, it counts the presence of about 130,000 tourists, concentrated in the summer period between June and August, and the stable presence of about 300 fallow deer that it moves among the garden, creating sometimes some problems. So Albarella is for us a perfect pilot area for our studies because we have the full traceability of the consumption and the production on different activities in the island. So the project is coordinated by Augusto and included several group of experts. Experts of the soil, we monitor the organic matter and the biodiversity in the different kind of soil with the aim to estimate how much organic carbon we can store in these soils and how. Experts in the use of bees as bioindicators in order to check the presence of pesticides and monitoring the quality of the environment in the island. Expert in botany to study how to make the island more natural, how to naturalize this tourist destination. So all the collected data are implemented in a system dynamic simulation model in order to simulate the carbon emissions balance in the period 2020-2050, assuming different situations, different scenarios. Here you can see a sketch of the model. The model takes into account the CO2 equivalent emissions by different sources and the sink in different kind of soil and vegetation. So one part of the model evaluates the emissions from fossil fuel consumptions, the emission from electricity consumption. In the island, an important consumption of electricity is linked is due to the water purification in the private aqueduct. Emission by different diets of the people in the island. We have continental, Mediterranean, vegetarian, etc. Emission from internal transport, emission from different management of the waste, different kind of waste. In fact, if you have, we have different impact if the waste goes to landfill or are recycled or are incinerated. And another part of the model simulate the potential sink of carbon sink of the new plantation. So in the various scenarios, we can assume different innovation in the short period, the available innovation as the, for instance, the utilization of photovoltaic for the electricity production also. Change the diet in the island, propose a change in the diet in the island, or change the internal transport, or plant new hectares of trees, or feed the soil with the organic matter produced in the island. So here in this slide, you can see the main source of CO2 equivalent in CO2 equivalent emission calculated that are the fossil fuel consumption, electricity consumption, and food consumption. Each one exceeds 4,000 tons per year. Here we have different scenarios characterized by different level of photovoltaic production and different diets. In the consumistic one, the current situation, there is no photovoltaic at all, and the storage is only by green areas and cover about the 12% of the total emission. In the sustainable scenarios, we assume that all the electricity is produced by photovoltaic. In the island, there is only a Mediterranean diet. In this case, the storage by the green areas could reach the 26% of the total emission. In the realistic one, so with a substitution of the 50% of electricity consumption by photovoltaic and a Mediterranean diet, the green areas cover about 80% of the total emission. Here in this slide, you can see the number of the different source, the different kind of green area storage. So concluding, how we can reach this goal of zero carbon emission. In our pilot, in our study, the photovoltaic and the change in Mediterranean change the diet. It's not enough. The green area contribute to the storage, but are not the solution to the problem. So we have to find other paths. For example, in our example, is important for sure reduce the fossil fuel consumption or introduce other renewable source of energy, increase the unrecycled waste, no, decrease the unrecycled waste, reduce, for instance, the tourist, but it is for sure impossible. So thanks for all. For the, this is my presentation.
Thank you, Cristian. So there is no solution, not at the moment.
At the moment, is pretty complicated. We can decrease, but in all the scenario, we have a net emission of CO2. So zero carbon emission in our situation, that is a pretty easy situation because there is no industry, there is only tourist activity, but also in this case, the zero carbon emission is practically impossible in the short term.
But the pandemic may have some effect.
What do you say, Klaus? Can you repeat?
The COVID pandemic
Okay.
may have some effects, so you should test it in your model.
Yeah.
Yes. I think this year probably we have zero carbon emission. No, last year.
Last year.
So only we have to consume less. This is the solution.
Yes, for seems the only solution in the short term. For on the short period, the only solution is to reduce the consumption. All the activities produce carbon emission in some way. We can reduce, but if we have an unbalanced situation between the pressure of the people and the and the capacity of the storage capacity of the nature, we can reach this utopistic zero carbon emission. The only way for me is reduce the density of the people on the planet. Now reduce but contain some way.
Please hang up and try again.